Okay, we're going to go over how to solve an inequality and graph it on the number line. We're using the New York State Learning Standard Integrated Algebra, the 21st Algebra Standard, determine whether a given solution is a solution to a given linear equation in one variable or a linear inequality in one variable. So we're going to focus today on the linear inequality part of that standard. Now, for the first thing that we want to do is we want to solve the inequality. So solve and graph solution and write your answer in interval notation. So three things: solve, graph, and write solution in interval notation. Okay, so in order to solve this, we're going to pretty much perform the same algebraic manipulations as we do on equations. And the first thing we would do if this were an equation, if this were negative 3x plus 4 is equal to 31, the first thing we would do is subtract 4. Okay, so I'm going to do that over here, subtract 4 from both sides. I have negative 3x is less than or equal to 27. Okay, now the next thing I would do if I had an equation is I would divide each side by 3. But as we saw in the previous lesson, and that's perfectly reasonable over here, divide each side by 3. But in the previous lesson, whenever you divide or multiply one side of the inequality by a negative number, you need to flip the inequality around. So you have x is, okay, and here you have greater than or equal to negative 9. So x is greater than or equal to negative 9 is the solution here, or it's represents the solution set. So any number greater than or equal to negative 9 would work here. So let's just check our solution by picking something here. X is greater than or equal to negative 9, so let's just choose negative 8. Okay, negative 8 is certainly greater than or equal to negative 9, so it should work. Let's put it back through the equation, or the inequality. Negative 3 times negative 8 plus 4 should be less than or equal to 31. So let's see, that's 24 plus 4 should be less than or equal to 31. And 28 is certainly less than or equal to 31, so that worked. All right. So, so we solved the inequality. Okay, our solution set is in the box here. And now to graph it, I have to do, I'll put negative 9. Let's see. I'm going to put negative 9 here, negative 8, negative 7. Let's put a few numbers on here. Negative 10, negative 11. Make sure that you put negative 7 to the right of negative 9. It's not okay to have a number line that looks like this. Negative 9, negative 8, negative 7. Right? The order of the negative numbers are the opposite of the order of the positive numbers, because negative 7 is greater than negative 9, because it's less negative. Okay, so it's not okay to switch the order of these number lines. Okay, so I have all the numbers represented on the number line, and then x is greater than or equal to negative 9 means that I put a closed circle at negative 9 because I'm allowed to include the value of negative 9. And I shade all the numbers that are greater than negative 9, including the arrow that indicates it goes off into infinity. Okay, now the solution set would be, so the lowest number I can include here is the number negative 9. Okay, and the highest number I could include here is infinity. So notice I can actually include negative 9, so I use a square bracket. And I never use a square bracket when including infinity. So that is these three things right here. The representation of the solution set with an inequality, with interval notation, and with graphing are three equivalent forms of the same thing. Okay, example 2, we're going to do the same thing. Now the first thing I want to do here, just as if I were performing the operations just as if I were solving an equation, I want to clean up the sides before I move on. So the first thing I want to do here is distribute this 2 in. So 2 times 2x minus 2 times 8 minus 8x is less than or equal to 0. Okay, so that's 4x is minus 16 minus 8x is less than or equal to 0. Now let's use keep, change, change. So we have k, c, 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 c here. So we have 4x plus negative 16 plus negative 8x less than or equal to 0. So now we have addition, so I can just add in whatever order I like. I can add those two terms together. So I have negative 4x plus negative 16 is less than or equal to 0. Okay, now I want to add 16 to both sides. So I have negative 4x on the left side. The less than or equal to symbol comes down, and 0 plus 16 is 16. Okay, now here I can divide each side by negative 4, but as in example 1, I have to be very careful. Whenever I multiply or divide an inequality by a negative number, I have to flip the inequality around. Okay, so I would have x is, and then I'm just going to do it up here, x is greater than or equal to, and 16 divided by negative 4 is negative 4. Okay, that is my answer, because before I had the less than or equal to inequality, but I divided each side by negative 4. Whenever you do that, you have to flip the inequality around. Okay, now to represent that on the number line, I would have negative 4 in the middle. Let's put a couple numbers to the side. Okay, so there's negative 3 on this side, negative 2, because any number to the right of another number on a number line has to be greater than it. So negative 3 is greater than negative 4. Negative 5 is less than negative 4. Negative 6 is less than negative 4. So since it's greater than or equal to, I'm going to include the value of 4 by shading it in. Greater than, it means I'm shading the numbers to the right. Okay, so I have that. Let's erase some of this work so I can see what I'm doing here. Now, this inequality and this graph both represent the solution set. If I asked you to represent the solution set with an interval notation, you'd have to say, okay, you can think of it sort of by looking at the graph too. This is a square bracket because that's the same as having a closed circle. The lower bound is negative 4, and I can go up to infinity with this inequality. So that is the interval notation for that. Okay, example 3. I have a compound inequality here. So I have a lower bound of negative 7. Right, it's the lowest number it can be. I have an upper bound of 0. Now, to solve compound inequalities, what I do is I consider 3 parts to it. It's like an equation with 3 sides to it. So you have a negative 7, you have this part, x minus 5, and you have the 0. So I have to maintain the same ordering relationship between all of these. So in order to get x by itself, to isolate x, I want to add 5. And I actually want to add it to all 3 parts of the compound inequality. So let's see. Negative 7 plus 5 is negative 2. Okay, since I'm adding a positive number, I don't have to worry about flipping the inequality, so I'll just leave that as a less than symbol. Now x minus 5 plus 5 is just x, and I'll leave this less than or equal to symbol, and 0 plus 5 is 5. Okay, so if x minus 5 is between negative 7 and 0, then x must be between negative 2 and 5. Okay, and we graph that. We put negative 2 here, negative 1, 0, 1, 2, 3. Let me make this bigger here. 4, 5. So 5 would be there. Okay, it's an open circle at negative 2 because I don't have an equality symbol there. It's just strictly greater than. It's a closed circle at 5, and there is shading in between. Now, to write this in interval notation, it's pretty much the same thing here. So I have a rounded circle at a rounded parenthesis at negative 2, because I can't include it. And it's on the left, just like it is on the number line. And then to the right is 5, and I want to put a closed parenthesis symbol there too, because I can include the value of 5. Okay, and that is, these are 3 ways to represent the solution set to this inequality right here, with a compound inequality, with a graph, and with interval notation. Okay, for our last example, we have another compound inequality. So it's a 2-step. Solving for this inequality involves 2 steps. So first I want to subtract 8 Now remember, you're going to subtract it from all sides. So negative 8, I want to subtract it from the upper bound of the inequality and the lower bound of the compound inequality here. Okay, so negative 6 minus 8 is negative 14. You can use keep change in order to see that. So you have negative 14 is less than, okay, I still have a negative 2 left inside, and is less than or equal to negative 4 minus negative 8 is negative 12. Okay, now you want to divide by negative 2 to isolate x, but remember this is dividing or multiplying by a negative number, so all of your symbols are going to flip. So let's see, negative 14 divided by negative 2 is 7. You want to flip that symbol around. Negative 2x divided by negative 2 is just x, and you want to flip the other symbol around, okay? And negative 12 divided by negative 2 is positive 6. So x is greater than or equal to 6 and less than 7. So another way of writing this is x is greater than or equal to 6, or 6 is less than or equal to x, I suppose you would read that as, and x is less than 7. Okay, so these two are equivalent forms. I prefer this one right here, right? Alright, so if you were going to write this, let's get myself some space here. If you were going to graph this, you would do a number line. Okay, 6, and you could put 7 here. Now x is greater than or equal to 6 and less than 7, so you can do that and shade in between. Okay, you don't have to shade the arrows because that you have an upper and a lower bound. And if you were to put this in interval notation, you would include the value of 6 by putting a square bracket, and not include the value of 7 by putting a rounded bracket. Okay, so that's the answer there. And you have your graph, you have your compound inequality, and you have your interval notation. Okay, and that's the end of learning how to graph and learning how to solve and graph and write in interval notation inequalities, including compound inequalities.